Okay, so here now we're just using the four-step process to solve the inverse trig relations. So the first step in the process is to identify the ratio that we're dealing with. Now this is sine here, so the square root of 3 over 2 is technically it's opposite over adjacent. That's how we ended up, or opposite over hypotenuse. That's how we ended up with square root of 3 over 2. Then let's think of the second part of the process. Like, where is sine positive? Because this ratio is positive. In which quadrants was sine positive? And so if you remember here with the four quadrants, so we could have a reference angle over here, and the y value, remember, hypotenuse is always going to be positive. So where is the opposite of our reference angle positive? The only two possibilities were in the first quadrant and the second quadrant. That's where sine was positive. At least that's how I think of it. You can also just go to your all students, take calculus and say, hey, S, that's in the second quadrant. And then all, so you know all of them are going to be positive in that first quadrant. So first and second, you could do it that way also. So now the next thing is, what we do is we take our reference angle and say what is opposite to that, and that's square root of 3. So we take our ratio, we identify that the first part of it is the opposite, and then the second part of it, the denominator, is the hypotenuse. So you write those right there on the two possible triangles, right? So those are the two triangles that could give us a sine value of the square root of 3 over 2. Now what we're doing is we're working backwards to figure out what the angle is. So let's just redraw this on another figure here. And remember, we're just looking from 0 to 360 for this. So going through the two triangles here. Now, if I had square root of 3 and 2, the type of triangle I'm dealing with is probably a 30, 60, 90, where one side is 1, the other side is the square root of 3, and then the last side is 2. So this is -1 here, but that doesn't affect my sine value, that just affects my cosine. So the 1 is on the short leg, so this up here would be 30 degrees, and then down here is 60 degrees. And then again here I have a reference angle of 60 degrees. That's the only way I get the same triangle. So 60 degrees here, and up here is 30. So at least I know my reference angle is 60 degrees. And so which angles can give me a square root of 3 over 2? It would be 60 degrees for sure. And then the other angle that could give me this ratio is over here. And that angle is 120 degrees. And that's it. That's my answer. So that's the arcsine of square root of 3 over 2, given that we have to find them in this range over here. Okay, let's do the next one. So step 1, identify the ratio. So cosine is adjacent over hypotenuse. That's what we're dealing with here on this part of it. And so where is cosine positive. Now cosine would be positive where x is positive, or you can do the all students. So all of them are going to be positive in that first quadrant, and then all students take calculus. So that's the fourth quadrant. So it's positive in the first and the fourth. So the two possible triangles are here and here. And then I've got my different ratios that I've got in this step here. So I put them on my thing here. So this is the square root of 3. And the hypotenuse is 2, hypotenuse is 2. And then this looks like a 1, 2 square root of 3 triangle. Now, if you didn't know that or didn't remember that for some reason on the test, you can always use the Pythagorean theorem and get the missing side that you don't know. Okay, so then I have this kind of setup here. These are the only two reference triangles that are possible. And so let's just blow up this figure again. And so what kind of angles am I dealing with here? So square root of 3, I've got 1. So 1 is going to be opposite my small angle. 1 is a short leg, it's going to be opposite the small angle. And then this over here, all the reference angles are going to be the same. So that's also 30 degrees. Okay, so now to figure out the angle, so the answer is 30 degrees, of course, and then if we go all the way around from our initial and over here to this location, that angle is 330 degrees. We're stepping just 30 degrees short of 0. So that's the answer for this. Those are the two angles in between 0 and 360, including 0 and 360, that could give us cosine of square root of 3 over 2. Okay, two more examples. So first we identify the ratio that we're dealing with here. So in this case, we would have to recognize that the square root of 2 over 2, this whole expression is the same as if we had written negative 1 over the square root of 2. And so in another one, you might see, I don't think there are any examples of it, but if you do see square root of 3 over 3, then that is the same as 1 over the square root of 3. So if you rationalize that, then this is something that comes out of it, where you have the square root of the number over the same number, and you can write it as 1 over square root of the number. Okay, so inverse cosine of negative 1 over square root of 2. So what is the possible, where are the possible triangles? And what is this ratio? Cosine inverse is adjacent over hypotenuse. So now in this case our ratio is negative. It's negative. So so we have all students take calculus, so all, and calculus is where the cosine is positive, so we're dealing with a second quadrant situation, second or third quadrant situation. So these are my two triangles. And my now I've got a negative here. This confuses a lot of students. We take the negative and we always apply it to our adjacent or our opposite. In this case, it's adjacent. We're using a positive hypotenuse all the time. Hypotenuse is square root of 2, and the adjacent for a reference angle is negative 1. then the missing side, you can always do the Pythagorean theorem, but if you know these kinds of triangles, this is a 45, 45, 90. So here we have -1 also for the opposite, and that's it. So that's our setup for our triangles. So let's take a look at what our angles could be. So we have 1 and 1 and square root of 2. So that's, I know it's a 45, 45, 90. So this is 45 degrees, that is 45 degrees. We really only care about the reference angle. So this reference angle is 45 degrees, and then this reference angle here is 45 degrees. So now what possible angles could my answer be? So if I go all the way over here, that is 135 degrees. And then if I am going all the way around to this location, that's 180. So about 180 plus 45, and then we have 225 degrees. Okay, so those are my two possible answers here. All right, so let's pick up the pace here. I think we've got the general process down. So now we have sine of -1/2. Let's write down, remember we're only looking for angles that are between 0 and 360. So this is opposite over hypotenuse. So where is sine negative? You know, sine is negative only in where the y values are negative. So these are my two possible triangles, here and here. And let's put then for opposite, we have -1, -1, and then this is going to be 2. You can always use Pythagorean theorem to find this side, but this is the square root of 3 and square root of 3. And so I don't need to draw this again. I know my short leg is opposite my smallest side. My short leg is opposite my smallest side. So now let's go through just calculating the angle. So I'm going all the way around and hitting this location. So 180 plus 30 is 210 degrees. Okay, that is the first possibility. And then if I go all the way around to this location, so that's 270 or 360 minus 30. So this is 330 degrees. Okay, that's my answer for this one. All right, now we're going to do a couple that they're a little bit trickier. So we have arctan of 1. So we have what angle makes a trig ratio of 1, a tangent ratio of 1. And 0, 1, and undefined are usually on the x or y axis, but in this case, tangent of theta equals 1. That's essentially the same problem. What angle gives you a tangent of 1 is a triangle. And we can find this. So first, let's write this ratio down. Now, there's only one number, but this is opposite over adjacent. And if there's only one number, you can always write it as divided by 1. Then let's make this triangle. So we've got, where is tangent positive? All students take. So in the first quadrant and the third quadrant is what we're dealing with. So these are our possibilities. So now let's finish this off by putting the trig ratio onto these triangles. So opposite over adjacent. So the positive, the first quadrant will be relatively easy. We have opposite over adjacent, so we're 1 and 1 there. And then in the third quadrant, things get a little bit tricky. Both of these values, even though it turns out to be 1, they both have to be negative. So that's -1 and -1. And then you can use Pythagorean theorem if you've forgotten, but if the legs are the same, then the hypotenuse is going to be the square root of 2 times the leg. So this is square root of 2, and this is also square root of 2. Then the final step here is to figure out these angles. So we know 1, 1, the square root of 2. This is familiar to us. This is a 45, 45, 90. The reference angle in both cases is 45 degrees. Okay, so now from 0 to 360, what are the possibilities? We have 45 degrees. That's a possible answer. So we're going from our starting point up there. That's the easy one. And then if we go all the way around to here, that's 180 plus 45. And so I get 225 degrees. Okay, so that's my final answer for that. Let's do a couple more with ones that end up in 0, 1, or undefined. Those are going to be ones on the x or y axis. So arc cosine. So essentially where we don't really can't really build a ratio from this one, but where is cosine equal to 0? And so the best way really is just to draw the axes out, and we've got our unit circle. And if you remember, this is all radius of 1, so this is 1, 0. This is 0, 1. And here we have -1, 0. And then finally 0, -1. And then just remembering back here for x and y values, we had cosine was the x and sine was the y. So looking at this here, where is cosine equal to 0? So we're focusing on the x value. So where could the cosine be 0? It could be 0 over here, and it could be 0 over there. And that's the only possibilities from 0 to 360. So looking at this now, then the only possibilities are you come from here and you go up to 90 degrees, and then you start here and you go all the way around and you go to 270 degrees. So that's the answer for this. So here. Okay, so arc sine of -1. So where is sine -1? So what angle gives us a sine of -1? We can go to this figure here. I don't know if I can use maybe a different color on it. Okay, let's use orange. So remember, sine is the y value. So where is y -1? The only location where y is -1 is at 270 degrees. So that's it. 270 degrees is the only answer for that one.